Covalent bond is formed between atoms of two nonmetals. Between two nonmetals, neither of the elements want to give up their valence electrons, so the elements end up sharing valence electrons. Let's see how we can represent that with the help of Lewis dot structure. Here's atom of phosphorus with 5 valence electrons, and here are 3 atoms of chlorine, each with 7 valence electrons. This chlorine comes to phosphorus and shares its unpaired electron with phosphorus. Phosphorus also shares one of its unpaired electrons with chlorine. Chlorine gets a full octet on its valence shell. Two other chlorines do the same, like a puzzle falling into the place. As a result, each chlorine ends up with having a full octet on the valence shell due to electrons shared by the phosphorus. And phosphorus as well has now a full set of 8 electrons due to electrons shared by the atoms of chlorine. When 3 chlorine atoms join phosphorus, all of the atoms end up with the full set of 8 electrons on their valence shells due to sharing of electrons. The shared pairs of electrons can be represented by a line between atoms. One line represents one pair of shared electrons. Lewis dot structure for molecule of water. Oxygen atom with 6 valence electrons, 2 hydrogen atoms with 1 valence electron for each atom. Sharing of electrons provides oxygen with full octet, and hydrogen atoms with 2 electrons on their one and only shell of electrons, which all that hydrogen needs for stability. Atoms of chlorine bind to other atoms of chlorine with covalent bonds, forming diatomic molecule of Cl2. The same happens to bromine, fluorine, iodine. A covalent bond of 2 shared electrons keeps together 2 atoms of hydrogen, another diatomic element. There are 7 diatomic elements on the periodic table. Atoms of the elements from group 17 and hydrogen are connected to each other with a single pair of electrons. Oxygen atoms are sharing 2 pairs of electrons. Nitrogen atoms share 3 pairs of electrons. A pair of shared electrons can be represented by a line, so you can see 2 lines between 2 atoms of oxygen and 3 lines between atoms of nitrogen.